Imagine the scene. It was 1871 and Charles Darwin had just suggested that we humans did not in fact walk fully formed out of the primordial sludge at the beginning of time. Instead, in his book, The Descent of Man, he proposed that humans descended from African apes. Naturally, his Victorian contemporaries were all, "Oh, fetch me my smelling salts," and clutching at their pearls and whatnot. And maybe you can't blame him for being shocked, because Darwin's idea is still shocking people like 140 years later. But, as he often was, Darwin was right. The amazing thing is that he proposed his theory of human evolution when there was almost no fossil evidence of any other kinds of hominins. That includes us and our ape-like ancestors on Earth. It took another 50 years for enough fossils to pile up to start corroborating Darwin's theory, and another several decades to piece together, compare, and argue about how these species related to each other. Actually, that's a process that's still going on right now. These days, about 24 hominin species or possible species have been identified, and while the hominin family tree looks sort of like a prickly bush at the moment, taken together, these fossils do show us how our ape-like ancestors evolved into modern human awesomeness. See, on the journey from genus Australopithecus to the genus Homo, our ancestors reached a series of game-changing evolutionary benchmarks, whether they were acquired traits or new behaviors that gave its species a huge advantage over the previous ones. We exist largely because of those evolutionary breakthroughs. So, what are they? And who else is in our family bush? And will this be on the final? Follow me into the facts of human evolution. Our understanding of where we came from has changed dramatically in just the last 50 years. If you were a paleoanthropologist working in the 1970s, you probably believed that there were a bunch of different human species running around on Earth for millions of years, and that they all sort of interbred when they bumped into each other. This is known as the multi-regional hypothesis, and it suggested that Neanderthals in Europe, for example, evolved into modern Europeans, while Homo erectus in China would have been the predecessor of modern Asians, and that Java man found in Indonesia would have been the ancestor to Australian Aboriginal peoples. These days, multi-regionalism has fallen out of favor, mostly because in the 1980s, researchers started studying mitochondrial DNA. That's the ancient DNA found in the mitochondria of our cells, which is totally separate from the DNA in our cells' nuclei. That's the stuff that we inherit from both of our parents. Mitochondrial DNA, on the other hand, is passed down only from the mothers to their offspring, and by following its various mutations over time and across populations. Scientists have been able to track the migration of humans over the past 200,000 years, all the way back to a single ancestral population of modern humans in Africa. This genetic evidence, combined with the fact that all of the oldest hominin fossils have come from Africa, led to the out-of-Africa hypothesis, which suggests that anatomically modern humans evolved exclusively in Africa and then spread across the world in two different waves. One wave, which happened anywhere from 70,000 to 125,000 years ago, took a right-hand turn out of Africa, populating the Middle East, Asia, Indonesia, and Australia. The second wave happened much later and headed straight up through Europe. So that's currently the most popular idea about where we came from, but when it comes to how hominins evolved, there are only a few things we're sure about. For starters, there did used to be a lot of different species of people running around, and now there's only one. And though we share the vast majority of our DNA with chimps, our common ancestor with them probably lived about 7 million years ago, maybe more. It was about 1 million years after that break with chimps that the Homo sapiens saga really began, when a segment of an ancient population of apes acquired the first real breakthrough in human evolution, bipedalism. This is when apes, somewhat obviously, started walking upright and on 2 feet. There were a couple of different early semi-bipedal genera of apes, and these probably evolved into the Australopithecines, who we can call Grandma and Grandpa. Australopithecines weren't that different from other ancient African apes. They were about the same size, and they had the same size brains. In fact, the first Australopithecines, like Lucy, the 3.2 million-year-old Australopithecus afarensis fossil found in Ethiopia in 1974, was probably about 1 meter tall and didn't look too different from a modern chimp. But we know that Lucy walked upright due to the shape of her bones, and because we found fossilized footprints of her buddies. And though there are a few different theories behind why bipedalism may have evolved, it seems to have happened just as the dense African forests were shrinking due to climate change. So early hominins may have been forced out onto the grasslands where bipedalism made it easier to spot predators, to travel long distances, and to pick fruit off trees. But bipedalism was most important because it freed up 2 of our limbs. When you got 2 hands just hanging out not doing anything, the next obvious step is to pick up a rock, start smashing stuff. And voila, you got an ape using a tool. And this led to the second major characteristic to advance human evolution, a precision grip. As hominins evolved, they used their hands more and more for gripping and manipulating small objects than swinging through trees and what have you. So over time, the big curved hands that we associate with chimps and gorillas were replaced with smaller, more nimble hands with powerful thumbs that you could see at the end of your arms right now. These hands were better suited for using slicing tools, and our first tool-making ancestor may have been Homo habilis, aka handyman. Homo habilis is the first obviously human-like hominin in the fossil record, and he's thought to be the earliest member of the Homo genus. He first appeared about 2.4 million years ago and was probably the direct descendant of the Australopithecines. I have to say probably because, you know, I wasn't there and there will always be holes in the fossil record. And Homo habilis probably couldn't have fixed your dishwasher, but he could totally have smashed it to pieces with a rock. In addition to acquiring more dexterous hands, Homo habilis ate meat. Its omnivorous diet was a new thing for previously vegetarian hominins, and it turned out to be another game changer for the genus Homo, because it kick-started the process of encephalization, or the growth of the brain in relation to the overall body mass. See, building and maintaining brains requires a ton of calories, so even though the first omnivorous hominins were probably scavenging gazelle scraps from saber-toothed cats or something, meat was a big enough part of their diet that their brain size increased pretty rapidly. Some argue that Homo habilis was also probably the first human ancestor to figure out how to cook food. Cooking unlocks all sorts of calories and nutrients from vegetables and tubers, as well as making rotten scavenged meat less dangerous. So overall nutrition for these guys improved a lot around this time, and brains, as a result, got bigger. But it wasn't just brain size that evolved, the pattern of brain growth was really important too. Over time, our ancestors' temporal lobes, which house the centers for language processing, and the prefrontal cortices, which help with complex decision-making and moderating social behavior, grew disproportionately to the other parts of their brains. Some researchers think this had a lot to do with the vastly improved diet, and at the same time, a need to solve social problems, which was becoming more and more important. One reason for this can be found in the fossils of Homo ergaster, which came on the scene around 1.65 million years ago. A lot of people think it's the descendant of Homo habilis. They looked even more like modern humans than Homo habilis. They had smaller jaws and sharper teeth, and were taller and more slender. They were also probably the first mostly hairless hominins. But one very interesting detail is that Homo ergaster had hips so narrow as to make the unassisted delivery of a baby very difficult. And since ergaster had bigger brains, their babies' heads were probably also considerably larger than those of past hominin babies. So, baby heads were getting bigger as females' pelvises were getting smaller. The only solution was for babies to be born before their brains were fully formed so that they could pass through the birth canal. But this meant that after birth, babies were less developed, requiring more care than ever, and for a longer time. This required ergaster and later members of the Homo genus to develop another breakthrough that could only be possible with big, sophisticated brains. I'm talking, of course, about complex social behavior. More so than anyone who came before them, members of Homo ergaster really needed each other. For delivering each other's babies, for caring for babies that took freaking forever to mature, for finding enough food to sustain everybody, and for hunting, which ergaster probably did in groups. It's also possible that Homo ergaster was the first human to leave Africa, maybe in search of better hunting grounds. Ergaster bones, dated to around 1.75 million years ago, have been found around the border of Armenia and Georgia. Shortly afterward, we start seeing the genus Homo erectus, the first early human whose fossils have been found in large numbers outside of Africa. And it seems like they did really well for themselves. Erectus laid tracks from Africa throughout much of Asia between 1.8 and 1.5 million years ago, and only went extinct around 27,000 years ago. They may even have been the first species to make sea voyages and build shelters for themselves. Homo erectus was kind of my favorite grandpa, or maybe great uncle, nobody's sure. Because during the heyday of Homo erectus about 400,000 to 600,000 years ago, we begin to see another species of hominin, Homo heidelbergensis, which some believe to be the direct descendant of Homo ergaster, since they were very similar with a couple of exceptions. Heidelbergensis had a much larger brain than ergaster. Some fossil skulls suggest that their brains could have been about as big as modern humans, and they seem to have been much more socially advanced. For instance, some scientists believe that Heidelbergensis was the first hominin species to bury their dead. But possibly the most important thing about Homo heidelbergensis is that many believe it's the direct predecessor to modern Homo sapiens, and possibly also to our thick-browed cousins the Neanderthals, aka Homo sapiens neanderthalensis, or Homo neanderthalensis. One theory is that a population of heidelbergensis remained in Africa, and modern humans descended from them, while other heidelbergensis hoofed it up through Europe, and Neanderthals derived from that group. This, like many other things in human evolution, is hotly contested. What we do know is that Neanderthals and modern humans actually hung out together for about 30,000 years. Neanderthals lived across Europe from 200,000 to 28,000 years ago, and though they had pronounced brow ridges and were heavier set than we are, they looked pretty similar to modern humans. Their brains seem to have been a bit larger than ours, and modern humans and Neanderthals apparently shared some cultural habits, like burying our dead, making art, and using tools to beat the crap out of each other. And of course, they totally found some time to get it on with each other. We've been able to reconstruct almost the entire Neanderthal genome, and it turns out that about 2.5% of our DNA is from some Neanderthals who, I guess, some of our great-great-great-great-great-great-great-great-great-grandmothers spent a crazy night with in a cave in Israel. So that brings us up through modern humans, but the story of our ancestry is always changing, because exciting discoveries are being made all the time. For instance, in 2004, researchers found fossils of Homo floresiensis, aka the Hobbit, a tiny person that lived until about 13,000 years ago in what is now Indonesia. Even more recently, in 2008, fossils of a new people, the Denisovans, or Denisova hominin, were discovered, who researchers think may have overlapped and possibly interbred with modern humans. And the discovery of Australopithecus sediba, also in 2008, has some paleoanthropologists in a dither about whether it could be the real direct progenitor for the genus Homo, and also the first tool maker. So it's an exciting time to be researching our origins. Nobody's really sure what killed off these other species. Some theories suggest it was climate change or a catastrophic event like a supervolcano eruption, or simply not being able to compete with this. Maybe we are the survivors because of our big brains, because we had to evolve to help each other out, and because we eventually developed agriculture about 10,000 years ago, which caused a huge population explosion that is still going on today. But now, it's just us, which makes me a little bit sad. It's pretty strange to think that if we went back in time just 100,000 years, like yesterday afternoon, geologically speaking, we'd be sharing the Earth with 6 different kinds of humans. Something tells me that playing Mario Party with a Neanderthal would be like a dozen different kinds of awesome, but I guess I'll never know. Thank you for watching this exceptionally long SciShow Infusion. We couldn't help it, there was a lot to cover. If you have any questions, ideas, please leave them down below in the comments or on Facebook or Twitter, and we'll see you next time.